Okay, so taking questions from Friday's assignment, from these right here. 5, 6, 9, 11, 13, 15, 17, 18, 27 through 34. Yes, ma'am. 32. 8, what? 18? 15. 5 and 6. Okay, yes. Baden.
27 and 29.
27, 29, Baden.
32.
Got that one.
34.
31, 34. Okay, these are the ones I have. Not every single, but a good many. Okay, all right, well, let's start chipping away at these, and then we'll look at the ones from Monday. Okay, so number 5. It says, if sine theta is equal to 0.45, find cosine of pi over 2 minus theta. Okay, let me get my sheet here. Okay, so I see this weird looking thing that I want to find, and those formulas, those identities, can be found in this bottom right box here. So cosine pi over 2 minus theta is right here, and it tells us that cosine of pi over 2 minus theta is equal to sine. So if this is equal to sine, and sine is 0.45, then this is also equal to 0.45. So I would just say cosine of pi over 2 minus theta is 0.45. And that's it. So just using that identity to realize that those are the same as each other. So then we're subbing in that 0.45 in the place of sine theta. Everybody okay with that? All right, number 6 is similar. It tells us that tangent pi over 2 minus theta is equal to negative 5.32, and we want to find cotangent. Okay, so let's go to that same box of identities. And over here I see that tangent of pi over 2 minus theta is equal to cotangent. So if I want cotangent, it's going to be the same thing as the tangent pi over 2 minus theta that I've been given. So it's also negative 5.32. These two things are the same. And question on 6. Okay, let's see, I think 15 might be the next one on our list. Okay, cosine x minus cosine cubed x. And the directions are use basic identities to simplify. Okay, so I can't subtract these because they're not like terms. But what I can do is factor out a common factor, which is cosine. So think about this. If you had x minus x cubed, then you could factor out an x and get 1 minus x squared. That's what we're going to do over here. So the thing that's common to both is cosine x times 1 minus cosine squared. And then 1 minus cosine squared, remember when you see ones and squared things, look in the Pythagorean identities. So taking that very first identity, if I were to subtract cosine squared over to the other side, then I would have 1 minus cosine squared equals sine squared. So this stuff in parentheses can be replaced with sine squared x. And really that's all that we can do with that one. That in itself is no identity. There's really no simpler way to write that, so that's it. Question on that one? Okay, next looks like 27. Alright, use basic identities to change the expression to one involving only sines and cosines. And we start with this. Tangent plus cotangent. Okay, so tangent plus cotangent by itself is not an identity. I think how I would start this one, and there is a couple ways to do this, but I think I would start by just distributing sine. Then I am going to change tangent and cotangent in terms of sine and cosine using this first little box on the top left here, our tangent identities. So I would have sine x tangent x plus sine x cotangent x. So the directions are telling us to change everything in terms of sine and cosine. So that's another clue to use this, because this box here is where I would find those identities to convert things, or these two things, in terms of sine and cosine. So tangent is sine over cosine, and cosine over sine is equal to cotangent. Now, these are multiplied, so you might want to think of those signs as being over 1. And let's keep going. So if I multiply these two together, I multiply straight across. So that sine times sine becomes sine squared over 1 times cosine is cosine. Plus, sine times cosine is just sine cosine over sine. Okay, so I have to change things to sine and cosine, but I'm assuming they would want us to get common denominators here. So, denominator would need to have each of these. So this first fraction would need to be multiplied by sine over sine. And the second fraction would need to be multiplied by cosine over cosine. What is sine times sine squared? Sine cubed. Right here. I could, with that, you know what, that might be faster. You gonna do that? Okay. Yeah, I didn't even see that, but I do think that might be faster. Okay, change of plans. And actually, I'm not going to need... Yeah, I'm not going to have to multiply that one. Thank you for catching that. I'll hold that off till the next step, so don't lose any money. Okay, cancel, cancel. So now I have sine squared over cosine plus cosine, and for seeing that I need a common denominator, I'm going to put that over 1. Okay, so now, as you stated, I will only have to multiply this one. The common denominator needs to be cosine. This one is already cosine. Cosine times cosine is cosine squared. 1 times cosine is cosine. Now what I don't want to do is reduce this, because that gets rid of my common denominator. Leave that alone. Denominator is cosine. But then numerator is sine squared plus cosine squared, which equals 1. So I have 1 over cosine. Now, since it said turn everything into sine and cosine, we could leave it that way, or, bless you, it'd be fine if you wanted to call that secant as well. So either one of those answers would be perfectly fine. question on that? Alrighty. That takes us to 29. Oh, 29. Oh, this one looks kind of crazy at first, doesn't it? All this stuff is multiplied together. Sine, cosine, tangent, secant, and cosecant. Well, that just looks like a bunch of mess, doesn't it? Okay, but let's do what the directions said and change everything in terms of sine and cosine. So I'm going to leave these two alone. Those are already in terms of sine and cosine. Don't change them to like 1 over cosecant and 1 over secant. That would definitely make things harder. But I can change tangent to what? Sine over cosine. And I can change secant to what? 1 over cosine. And I can change cosecant to 1 over sine. Okay, so the three things that weren't already sine and cosine, I just changed those. Now look, all of this stuff is being multiplied together. If it makes it easier for you, you might want to think of those as being over 1. And since they're all multiplied, I see no pluses or minuses. Any common factor top to bottom can be canceled. So here's a cosine. Here's a sine. And so the only thing I'm left with now is sine over cosine, which is tangent. That one works out kind of nicely. Any questions on that one? Okay, 31. Tangent x over cosecant squared plus tangent x over secant squared. Okay, now this looks a little weird. What should we do with this? This is still in that group that says change to sine and cosine. So we got a lot of changing to do, like everything. So I'm going to change tangent to sine over cosine. Over, what can I change cosecant squared to? 1 over sine squared. Okay, plus tangent, again, sine over cosine, over, and this would become 1 over cosine squared. Okay, so we'll need to do a little keep, change, flip, simplifying here. Okay, so sine times sine squared, that ends up being sine cubed over cosine, plus sine times cosine squared over cosine. Okay, well, the only good news I see so far is that we already have common denominators, so I can combine them into one fraction. That denominator will be cosine. And I'll just have sine cubed plus sine cosine squared. All right, ideas of what we'll do next. Factor out a sine. I see a sine in both terms. Those terms are not like terms, so I can't actually add them together, but I can factor out that common term of sine, which gives me sine squared plus cosine squared over cosine. And this lovely guy here is equal to 1. So I really just have sine times 1, which is sine, over cosine, and sine over cosine is tangent. Okay, that took a lot of simplifying, but we finally got there. Any questions on that one? Are you following along with that? Okay, 32 is next. 32, secant squared x cosecant x over secant squared plus cosecant squared. Alrighty. Is secant squared plus cosecant squared anything that we can simplify in the Pythagorean identities? It's not, is it? Because you have secant squared here, cosecant squared here. Okay. Let's see. Any ideas? I'm just kind of thinking out loud here. This is 1 over cosine squared times 1 over sine over that. Combine the fraction. What are our directions here? Oh, same thing. Okay. All right, well, I guess we better change this too. Okay, not seeing it yet, but we'll get there. All right, 1 over cosine squared sine. I'm just multiplying those two together to get that. Over 1 over cosine squared plus 1 over sine squared. Okay, we're going to have to get common denominators down here. So just hold tight on the numerator there. My common denominator, you'll tell me if you found a quicker way to do this one. Common denominator will have to have sine squared and cosine squared in it. Okay, so I have 1 over cosine squared sine over sine squared over sine squared cosine squared plus cosine squared over sine squared cosine squared. Now, is sine squared cosine squared 1? Not if it's multiplied, right? Just if it's added. So all I can do so far, go to a new page, is combine these together into one fraction because they do have common denominators. So that will look like this. I will still have my 1 over cosine squared sine over sine squared plus cosine squared over sine squared cosine squared. Okay, so all I did there is combine those two fractions into this one. Now, let's do a little keep, change, flip. So I'm going to keep, change to multiplication, flip this one, okay, And I do see finally some little light at the end of the tunnel because, oh dear. Is that supposed to be squared? Did I mess up somewhere? Is that one squared? No. Shoot. Okay. Part of it will cancel then. So the cosine squared will cancel. And this sign will cancel with one of those. So I still have one sign left over. Okay. So left over up top is just a sign. This one's a booger, isn't it? Over sine squared plus cosine squared. That's equal to 1. So I just get sine. All that for sine x. Whew, that was a lot of work. $32. All right, question on that one? You might find a shorter way to do that one. No, dang. All right, 33. Okay, new set of directions. Combine the fractions and simplify to a multiple of a power of a basic trig function. All right, 1 over sine squared plus secant squared over tangent squared. All right, what should we do? What is this equal to? Secant squared, we might need that. Let's leave it alone for now. Let's work on this one. I think I would change everything to sine and cosine over here. So this will become 1 over cosine squared over sine squared over cosine squared. So there's the secant squared, there's the tangent squared. If I do a little simplifying here, that one stays the same, but I'll have plus cosine squared over cosine squared times sine squared. Okay, well, I do see those factors that cancel. If there had been a plus in between there, I couldn't do that, but because they're multiplied, I can. So now I have 1 over sine squared plus, there's a 1 over sine squared. Well, that's cosecant squared plus cosecant squared is what? 2 cosecant squared. Fun, fun, fun. Any questions on that one? All right, 34. 1 over 1 minus sine plus 1 over 1 plus sine. Okay, so close, yet so far away. Those denominators are not the same. We're going to have to make them the same. So each one will get multiplied by the other. And this one, 1 plus sine x, 1 plus sine x. Okay, so 1 plus sine x times 1 is 1 plus sine x. Over 1 plus sine, 1 minus sine, plus 1 times 1 minus sine is 1 minus sine, over 1 plus sine, 1 minus sine. Woo! Okay. I have common denominators, so I can add up the numerators. 1 plus 1 is 2. Sine plus negative sine is 0. So I really just get 2 over. Should we distribute? If we distribute, what do we get? Hello? 1 minus sine squared. And what is 1 minus sine squared? Cosine squared. And 1 over cosine squared is secant squared. I just have 2 of those. So it's 2 secant squared. Do we see where this led to that? FOIL it out and those two middle terms will cancel. Any questions? So those of you not writing, you already got it? Any questions? All right, let's go to Mondays because we added to this. Not quite as many. Of these problems, what do we need to look at? What do we need to look at? Yes. 52, 53, 54. Okay. 55. What else? 51. The 50's gotcha, huh? 39, 41, 48, 49, we're okay? Do you care which one? Does someone have a preference of these first four? Let me see which one I think looks worse. 41? Okay. All right, so start with 41. One minus 2 sine x plus 1 minus cosine squared. Now, it was very nice of the textbook to put this 1 minus cosine squared in parentheses because I'm going to go to those Pythagorean identities and see that 1 minus cosine squared is the same as sine squared. Okay, now I don't really like the order of that. What is it we're doing with this? As a single trig function. Okay. So I'm going to rearrange it. Like that. Now, if I gave you x squared minus 2x plus 1, do you see how those are similar? Okay, so what can I do with this? Hint, hint, factor. Okay, you could do this, right? And then 1 times 1 would be 1, and a negative 2 on the bottom. And what two magical numbers do I need over here? Negative 1 on both of them, right? Because negative 1 times negative 1 is 1. Add them up and we get negative 2. So that tells me that my factors would be x minus 1, x minus 1, or x minus 1 squared. Okay, when your lead coefficient is 1, then that's all the work we need to do. So this is the same exact thing, but my x is not x, it's just sine x. Okay, so my factors would be sine x minus 1 times sine x minus 1. If I did this like by guess and check, I would say, okay, what two things do I multiply to get sine squared? I'd have to multiply sine times sine. And then I go to the 1. What two things would I multiply to get 1? A 1 and a 1. How on earth can I get a -2 sign in the middle there? If both of these are minus. And then a -1 times a -1 would give me a +1 there. Okay, and if I have, so you can see how that factor and this correspond. And if I have two of the same thing, I can just write that sine x minus 1 squared. You could also leave it with two of them. Question on that one. What now? Because if I FOIL it all out, this gives me negative sine x, which is -2 sine x in the middle, and then -1 times -1 gives me +1. Okay, any other questions on that one? All right, let's tackle our 50s here. Okay, so these are, I don't know, did you think these were easier when you were solving the equations? I think in general they are, because you at least have some direction that you're going. Okay, so directions are find all solutions in the interval 0 to 2 pi. Okay, so this is important. So, did I get that bracket in the wrong place? I did. That should be a bracket here, parentheses here. Okay, so this is telling me, you know, on the last test when I said there's principal trig functions, we're only looking in 2 quadrants. This is telling us not to do that. This is saying look on the entire unit circle and find any answers that fit these descriptions that we get to in just a minute. Let me get my unit circle handy. Okay. So, what do we do with this? I can't add them. They're not like terms, but what do you see in both terms? Cosine. So I'm going to factor out a cosine x. When I bring out that cosine, I will have a 2 sine x minus 1 equals 0. Okay, if any two factors are multiplying to give us 0, the only way that can be true is if at least one of these is 0. So we set them each equal to 0. That one, I'm ready for the unit circle. This one we need to do a tad bit more work. I'm going to add 1 over and then divide by 2. So I'm looking for any angle 0 to 2 pi, not including 2 pi, where cosine is 0. Well, your cosine is your x-coordinate. So I find a cosine of 0 here and here. Now, if this domain is written in radians, then we want to answer in radians. So I would say that x equals pi over 2, 3 pi over 2. That takes care of where's cosine 0. Where is sine 1/2? I will have two answers there. Sine is your y-coordinate. That's going to happen over here at pi over 6, but it's also going to happen over here at 5 pi over 6. So in addition to these two, I have pi over 6 and 5 pi over 6. Now, there's no way of looking at the original equation and knowing how many answers you'll find. Now, when we have a quadratic equation, we know we should find 2. There's no way of knowing that on these, so it's just kind of a surprise each time how many answers we get. Any questions on 51? All right, 52. Square root 2 tangent x cosine x minus tangent x equals 0. Okay, so this is kind of similar to the last one. I can't add those two terms. They're not like terms, but they do have a common factor. In this case, that common factor is tangent. So I'm going to bring that out. That leaves us square root 2 cosine minus 1. I have two factors that are being multiplied to give me 0. Therefore, I'm going to set each of these factors equal to 0. Like that. Okay, I can go to the unit circle for that. This one needs a little bit of work. I'm going to add 1 and divide by square root 2. And I get cosine x equals 1 over square root 2. Now, I would say this is ready for the unit circle to find answers, but you're not going to find an exact match for the way this fraction looks. But if we rationalize that, then we will find some answers that match with that. So I'm looking for where cosine is square root of 2 over 2. Cosine is your x coordinate. Square root of 2 over 2 and square root of 2 over 2. So that is pi over 4 and 7 pi over 4. Now let's go back to this. How do I find tangent on the unit circle? Y over x. If I want y over x to be equal to 0, what has to be true? If I want, y'all look at this up here. If y over x is 0, which one? Y. If x is 0, that's undefined. So I'm really just looking for where is y 0? Well, that's at 0 over here far right, and also over here at pi. So I'm going to add to my list 0 and pi. I don't include 2 pi because we have the parentheses on 2 pi, bracket on 0. So I call it 0, I don't call it 2 pi. So those are my 4 answers. All right, are we doing okay? All right, 53. And just think I get to do all these again next block. I bet it'll be the same ones. Okay, tangent x sine squared equals tangent x. Okay, true or false? First thing I need to do is divide everything by tangent x. False, because that is getting rid of a solution. If there was just a 2 here and a 2 here, then absolutely divide by 2. But don't divide by what your variable is, otherwise you're ditching a solution. So, unfortunately, I've got to subtract this over so that it's equal to 0. Okay, so I want to set it equal to 0. And similar to the other ones we did, I can't combine these. They're not like terms, but I do have a common factor of tangent x that I will factor out. Okay, once I have these two factors and their product is 0, then I set each one of these equal to 0. Okay, if we add 1 to both sides, and I square root both sides, am I looking for where sine is 1? Positive or negative 1. Don't forget to do the plus or minus. Okay, so I'm looking for where tangent is 0, where sine is 1, or negative 1. Okay, and just like we said a minute ago, tangent is y over x. So if I want y over x to be 0, I'm really just looking for where y is 0. We already answered that question above, so we know that that is 0 and pi. Where is sine 1 or negative 1? Sine is your y coordinate. It is 1 up here at pi over 2. It is negative 1 down here at 3 pi over 2. So I'm going to add pi over 2 and 3 pi over 2 to my solutions. Questions on 53? Sam, we're good? Okay. You had a puzzled look on your face. 54. Sam, when did you start wearing glasses?
When did I start?
Mm-hmm.
When I was
8th grade. Okay. I have my son started wearing when he was 4. Felt like Mother of the Year when he came home with his little I failed my vision test from pre-K. And I have been the cause of many students getting glasses over the years. Because if I sit out here and look at you guys all the time and someone is constantly doing this, like you were the other day without your glasses, and I'm like, call home, and next thing I know, they come to school with glasses and they can see. All right. Sine, tangent squared equals sine. Baden, what do we do first? Subtract sine. Do not divide by sine. Hannah, when did you start wearing them? 6. You don't. All right. I'm going to do what with that sign? Factor it out. Haley, when did you start wearing yours? 8th. I think my daughters were 2nd grade and my son was pre-K. Ooh, tangent squared minus 1. That makes me think to look at that, but ooh, that doesn't work. So let's not mess with that. Just a thought. Didn't work though. Let's just set them equal to 0. Okay, I'm going to add 1. I don't want tangent squared, I want tangent, so I'm going to square root, and I'm never, ever, ever going to forget that plus or minus. Okay, so where is sine 0? Well, wherever y is 0, which is here and here. So 0 and pi. Okay. Where is tangent 1? We found tangent by dividing y over x. So how would I get 1? If they were the same number. The only place that happens is here at pi over 4 and here at 5 pi over 4. Now, let me go ahead and add those. What about tangent equaling -1? Well, they're going to be the same number, but one will be positive and one will be negative. So that's our other 45-degree angles, our 3 pi over 4 and our 7 pi over 4 is where we will get that tangent of -1. I want where sine is 0. So that means the y value is 0. Okay, any other comments or questions? Okay, last one on this page. 55. Tangent squared is 3. Well, that looks simple. Nothing to move, nothing to factor. I've just got something squared equals a number, so I'm going to square root. And I'm going to remember my plus or minus square root of 3. Okay, so Caden, we find tangent by dividing y over x. If I'm going to get a square root of 3, I've only got certain options. Like, it's not going to be from these numbers, right? That's not going to give me a square root of 3. It's either going to be this order pair or this one. And then I'll go around and find the corresponding ones in the other quadrants. So if you're not sure, use your calculator. But which one of these y over x would give me square root of 3? The pi over 3, or the 60 degrees. Okay, so because it can be positive or negative, I'm just going to go with that corresponding order pair in every single quadrant. I'll get positive where they're both positive and both negative, but I'll get the negatives in the other two quadrants. So it's going to be pi over 3. Move on around, that's going to be 2 pi over 3. Move to your third quadrant, we've got 4 pi over 3. And then lastly, we've got 5 pi over 3. So there's one answer from each quadrant there. Whew. Question on that? Huh? All right, let's go ahead and turn those in, and then we'll take questions on 5-2. You will probably have multiple papers there, so staple them together if you do. Hey, you can go if you need to real quick. Okay, next, find your homework from 5-2. I know, that's on page 418. Now, oh, you did too? Did you not have questions on them?
I already said
5-2, what questions do we need? 1, 3, 14. 21, 23. 15. Ooh.
You should have left us.
Couldn't help it.
Nobody can explain that like Miss Campbell can.
Oh, okay. Now, so some people think that these are easier because you know exactly where you're headed and you know when you're done. Okay? So the important thing on these is to just change one side. So let's look at a few. Maybe I'll do like one from each section and then let y'all keep going back and working on some. Because remember, we're not doing a new lesson today. So let's set up, okay, look at the problems. Do you want to do 1 or 3 together?
3.
Personally, I think 3 is a little harder. Do 3? And then I'm going to let y'all go back and work on 1, and I'll just walk around and answer questions. Y'all can work together. Okay, so clearly this is not trig related. It's just an algebraic statement here. Okay, so directions are prove the identity by starting with the left-hand side expression and supplying a sequence of equivalent expressions that ends with the right-hand side expression. Okay, so like I explained in the video yesterday, on these, generally we want to start with the hard side because that gives you more to work with. So I would say start with the left, don't do anything to the right, until the left becomes the right, then you know you're done. Okay? So I'm going to just totally not touch the 5, but that tells me where I'm headed. I will be done when I change this side to be 5. Okay, can I cancel this x with one of these? No, because x is not a factor. I can't factor out an x, top or bottom. But what I hopefully will recognize is that this is a difference of two squares. We have those conjugate factors. This is also a difference of two squares. Conjugate factors, meaning they're identical except one's plus, one's minus. Okay, then I see that within each fraction I do have a common factor that will cancel. And so now all that I have left over is x plus 2 plus x minus 3. Okay, well that gives me not what I wanted. What did I do wrong? Ah, there's a minus in between? That would make so much more sense. Yes, this is a minus. And I was like, ooh, we're not getting there. Minus. Okay, so I'm going to leave it this way first. Minus x minus 3. Then I'm going to distribute that negative and get x plus 2 minus x plus 3. X minus x is 0, so that is 5. Voila, that is what I was looking for. Your work is your answer on this. So that whole thing is your answer. Okay? All right, so you're going to go back and do 1 for me. Let's see. Next up, we had 5, 6, and 7. Okay, look at 5, 6, and 7. What looks worse? Y'all didn't ask for any of those. Does that mean you don't need those? You give us 6. Which one?
Whatever looks right.
Okay, we'll look at 6. Okay, so these directions are a little different. It says in 5 through 10, tell whether or not f of x equals sine x. So this is what we're being asked. Does f of x equal sine x? Okay, so basically we just want to simplify this, and we'll either simplify it down to sine x or we won't. Okay, so how would you tackle that? What do you think I'm going to do? Make it sine and cosine. You got it. All right, so I'm going to change that to sine over cosine. That's the tangent. Over secant is 1 over cosine. And then if we simplify that, I will get sine cosine over cosine times 1 is cosine. I do have common factors of cosine that cancel, so that does equal sine x, and my answer would be yes. Okay. All right, let's see. Moving on down, then we have number 11 and 12. Okay, prove the identity. Does anyone struggle with 11 or 12 over the other one? 11? Okay. And if you haven't done 12 then, I'll let you tackle that next on your own. Okay, cosine times tangent plus sine cotangent equals sine plus cosine squared. Okay, so which side do I have more to work with? The left. Yeah, like if I were going to change that, I don't even know what I would do. Everything's in sine and cosine. This one I definitely have some more to work with. So that's exactly what I'm going to do. And I think I'm going to distribute this first. So don't touch the right at all. Just manipulate the left, keeping in mind that this is what we're headed for. Okay, so this is cosine tangent plus cosine sine cotangent. Okay, I think what I would try next is changing things to sine and cosine. Leave the sine and cosines. So this will stay cosine, but I'm going to change tangent to sine over cosine. Plus, leave cosine, leave sine, but change cotangent to cosine over sine. Okay, so right here I see a common factor top to bottom. These are both over 1, but I do see this sine and this sine that would cancel top to bottom. Only because they're multiplied, they cancel. Okay, so what's left here is just sine. Look at what we're headed towards. Do you see that we're there? Plus cosine times cosine is cosine squared. And that's it. So that work is our answer. Alrighty, let's see. So 12 is going to be very similar to that one. Let's see, 14 and 15. I'm assuming y'all would think 15 is a little bit harder. Let's try 15. Okay, directions are just prove the identity. 1 minus cosine u times 1 plus cosine u over cosine squared equals tangent squared. So left-hand side definitely gives me more to work with. I'm going to distribute this out. Like everything's already in terms of sine and cosine. So let's FOIL this top out. That gives me 1 plus cosine u minus cosine u minus cosine squared over cosine squared. Now, please don't cancel these cosine squareds. This is not a factor of the numerator. It is a term. But these do cancel. They just add up to be 0. And so all I have left is 1 minus cosine squared over cosine squared. Now, that is still not something that cancels because of that subtraction there. But what is 1 minus cosine squared equal to? Sine squared over cosine squared. Keep glancing back. What is it we're trying to get? Tangent squared, and we're there. Alrighty, let's see. 17, 19. 19, all you can do there is FOIL, and then you are done. So if you didn't get 19, go back and look at that one again. That beta is the letter, the Greek letter that they're using there. If you don't like it, use theta or x. Let's look at 17. Did any of you look at the solutions and decide that they did some of these a harder way than necessary? I think with these, that I personally think that they sometimes take the long route. Okay, I think I would start with the left. Leave the right alone, but keep in mind that's what we're aiming for. Negative tangent times sine. Can I do anything with the numerator? This one's a little weird. It's cosine squared minus 1. Let's look at sine squared plus cosine squared equals 1. That's that first Pythagorean identity. I have cosine squared minus 1. So if I subtract 1 from both sides over here, I have sine squared plus cosine squared minus 1 is 0. I just want these to be alone. So that means I'm going to have to subtract sine squared from both sides so that I have cosine squared minus 1 is negative sine squared. Okay, so this numerator is negative sine squared over cosine. Okay, now that's pretty simple as is, but look what I want it to be. Negative tangent times sine. Okay, so how we're going to get there is I'm going to do this. I'm going to say this is negative sine over 1 times sine over cosine. Look at that and see if you can tell what I did. Broke it apart into two fractions. I have a negative sine squared. That's equal to negative sine times sine. I just have a cosine here. That's equal to 1 times cosine. So, what is this equal to? Just negative sine. And what is this equal to? Tangent. Keep looking back at what you want. So this is negative sine times tangent, which, because multiplication is commutative, is the same as negative tangent sine. Good. All right, 1920, 19 I already said is distribute. 20, 21, and 23. Okay, 23 is not terrible. Let's look at 20 and maybe 21. Okay, number 20. 1 over 1 minus cosine x plus 1 over 1 plus cosine x equals 2 cosecant squared. Say what? Okay, while the left is the one we need to start with because I have more to work with, that's already pretty simple, like I can't replace anything. So what I would do here is add these together, but I can't do so until I get common denominators. So each denominator will multiply the other fraction. So this one will multiply by 1 plus cosine. And this one, I didn't leave much room, multiply by 1 minus cosine. Leave the right alone. Okay, so when I multiply this, 1 times that is 1 plus cosine x over 1 minus cosine times 1 plus cosine plus 1 times 1 minus cosine is 1 minus cosine over 1 plus cosine, 1 minus cosine. Okay, keep in mind what we're looking for. Do I want to cancel those? If I cancel, I'm going right back to what I started with. So I'm like that hamster on a wheel, right? I like keep getting back to what I started with. So don't cancel, even though we could. But I'm going to distribute on the bottom. So I have 1 plus cosine over. Okay, if I distribute this, that's 1 plus cosine minus cosine cancels, minus cosine squared. Stop me if I lost you on that. Over here, I have 1 minus cosine over, I'm going to distribute this, I'm going to get the same thing. Okay, I still can't cancel anything because I don't have any common factors. Keep looking back at what we want. 2 cosecant squared. Okay, but now I do have common denominators at least. So let's go ahead and add up the numerators. 1 plus cosine x plus 1 minus cosine x all over denominator. Well, cosine and negative cosine, those add up to be 0. So that's 2 over 1 minus cosine squared. Okay, so to see where the 2 is coming from, where is cosecant squared going to come from? What's the bottom equal to? Sine squared. And then 1 over sine is cosecant. So 1 over sine squared is cosecant squared. And then you have a coefficient of 2. So that does equal 2 cosecant squared. All right. You have 15 more minutes. I want you to go back and work on the ones that you are still missing. And I will help you if you need it. Or please help each other because that will help you even more if you're helping someone else. And tomorrow we will carry on with a quiz. And please have your notes organized and things like that before the quiz.